Let's find the sum of the infinite series. Say we have sum from n equals 2 to infinity of 1 over n squared minus 1. So this one looks like it could be a telescoping series. And to check, I want to rewrite this as 1 over n minus 1 times n plus 1. So I can break up this denominator. So a good way to do this is we know that the telescoping is going to have two fractions subtracting with each other. And each fraction is going to have the denominator of the other. And I'm just going to put a and b here. So I can multiply the diagonals, really. So that'll be a times n plus 1 minus b times n minus 1. And then the denominator is just going to be them two multiplied. Okay, so if we compare with what we have here, I want the n's to cancel. Okay, so if the n's are going to cancel, that means a and b have to be the same. A has to equal b. Right, so another way to write this is if I distribute out the n is the same thing as a minus b. And then, so if I distribute out the n's here, and then if I do the a's and the b, that would be a plus b. Okay. That's over n minus 1 times n plus 1. So a has to equal b, and then a plus b has to equal 1. Okay, that's this over here. This has to equal 1. So if a is equal to b, basically you have 2a equals 1. So a has to equal a half, which is also b. Okay, so our sum, 1 over n squared minus 1, we found a different way to write this. It's 1/2 over n minus 1 plus 1/2 over n plus 1. And for us, we know that because these are two apart from each other, n minus 1 to n plus 1, like to go from n minus 1 to n plus 1, you have to go, just two away from each other. The answer is going to be this, the first two terms of this. So it's going to be 1/2 over 2 minus 1 plus 1/2 over 3 minus 1, which it's going to be, let's see, 1/2 plus 1/2 over 2. It's 1/2 plus a fourth, which is 3/4. Okay, so this is the shortcut to doing this problem. Now let's actually do it the long way. Now I'm going to rewrite this as, well, first I'm going to distribute this 2 to both denominators. So I'm going to have it as 1 over 2 times n minus 1 plus 1 over 2 times n plus 1. So it's still going to be the sum. Sorry, this is minus. Sum from n equals 2 to infinity. So if I do n equals 2 first, that's going to be 1/2 minus 1/6. And then plus, for n equals 3, we'll do 1/4 minus 1/8. For n equals 4, if you plug it in, you get 1/6 minus 1/10. And then for n equals 5, you get 1/8 minus 1/12. And so you just continue like this forever. But this is enough to get a pattern, because you notice that 1/6 cancels, 1/8 cancels, 10th is going to cancel when n equals 6. The 1/12 is going to cancel for n equals 7. Okay. So what you're going to be left with is the 1/2 plus the 1/4. That's exactly what we had over here. So the final answer is 3/4. Okay. So we just verified the shortcut works.